Hi, good morning to everyone. This is Jaswanth. First of all, I wish you a 75th Happy Independence Day. Today, we are going to discuss the subject chemistry topic balancing chemical equations. This is used in various exams and very important topic and interesting topic. Let us take an example and solve this. Fe plus H2O gives rise to Fe2O3 plus H2. How to solve this? First, we have to write on our book elements, reactants, products. Reactants means this side and products means this side. Elements means what elements are there in this equation we have to write here. First one, iron. Next one, hydrogen. Next one, oxygen. Now, reactant side, how many atoms are there? For iron, only one atom. For hydrogen, two atoms. And oxygen, one atom. Now, product side. Iron, two atoms. Oxygen, three atoms. So, oxygen, three atoms. Hydrogen, two atoms. Now, we can understand that it is unbalanced due to in reactant sides and product sides there are no equal atoms. We have already said that in product sides and reactant side if you have equal atoms, that is known as balanced equation. Now, how to balance this? First, here one atom is missing, so we have to multiply it with 2. And here this is balanced. Here oxygen, 3 atoms. So multiply it with 3. Now we have multiplied in reactant side with 2. So for iron keep 2. Next, oxygen multiplied with 3 on reactant sides. We should not keep wherever oxygen is there, we should not keep 3. In which side we have multiplied with 3, that side we have to keep. Now 3. But here hydrogen is getting 6 atoms on reactant sides. So we have to also multiply in product sides for hydrogen into 3. Now, in reactant sides for iron, 2 atoms, 2 atoms. For hydrogen, 6 atoms, 6 atoms. And for oxygen, 3 atoms and 3 atoms. Now, this is the balanced equation. Let us write it. 2Fe plus 3H2O gives rise to Fe2O3 plus 3H2. This is the balanced equation for Fe plus H2O gives rise to Fe2O3 plus H2. The next topic we discuss is law of conservation of mass. For this we need an example. 2NaOH plus H2SO4 gives rise to Na2SO4 plus 2H2O. For this we need to take balanced equations. Do not take any time unbalanced equations. First we have to know the weights of these elements. First one, Na weight is 23 and for oxygen 16 and for hydrogen is 1. And here what is another element? Sulfur. Sulfur is 36. Now, what is law of conservation of mass? In reactants and product sides, if you have same masses, that is called law of conservation of mass. Now let us check this is in a law of conservation of mass or not. First, let us take their masses. This is reactant sides, product sides. No reactant sides. Now 2. 2 into sodium, how much? 23 plus oxygen 16, hydrogen 1 plus 1 plus, now hydrogen into 2, 1 into 2 plus sulfur 36 plus oxygen 4 atoms means 16 into 4. Now let us check how much we got. 2 of what? 23 into 23 plus 16 plus 1, 40 plus 1 into 2 plus 36 plus 64 plus 36, 100 plus 2, 102. We get 178 grams. 182 grams. Now on product sides, sodium into 2, 23 into 2. 23 into 2 plus sulfur 36 plus oxygen into 4 means 16 into 4. 16 into 4 plus 2 into hydrogen into 2 means 1 into 2 plus oxygen means 16. 16. Now this also we get 182 grams if we check. 182 grams. Now reactant size LHS is equals to RHS. Now we can say that this equation is applying the law of conservation of mass. Today we have discussed two topics. First one, balancing chemical equations, and next one, law of conservation of mass. Thank you.